We're going to take a look at some questions that you're being asked on your take-home test today. So let's take a look at this right here. We have a source of voltage here. The symbol letter E is just very general for any battery. It could be any voltage at all. And we see that there's a resistor here, and it is given a value of R. And all of these other resistors are also given values of R. And we have a switch right here, initially open. So let's trace the path of electricity. So this is the positive of our battery, that's the negative. So electricity is going to flow out. It'll go through this resistor. Okay, it will not go this path initially because that switch is closed. And then it'll flow through this resistor, going around here, okay, to ground. So initially we just have a simple series, and your resistance total for that is going to be R plus R, which equals 2R. And then you can figure your current by using V equals IR. So in this case, E is equal to I times 2R. So then your current equals E divided by 2R. Okay, so that's how you can do that pretty easily there. And you can kind of compare power and things like that just using that. And again, E could be any value. If you're more comfortable just putting numbers in, you can put a number in for your volts and a number in for your resistance. Now what happens when we actually close this switch? So I'll do that. I'll just put a dash line here. We now complete that circuit. So now the current will come here, go through this resistor, reach this juncture, and then we'll make this parallel branch and also this parallel branch. So what would our resistance total be now? Well, you've got to get the resistance parallel first. So I'll say 1 over R parallel is equal to 1 over R plus 1 over R. So 1 over resistance parallel is then going to equal 2 over R. Now you need to invert this to get resistance parallel. And that's going to be R divided by 2. So you can think of this branch here as R divided by 2. So let's redraw a quick circuit here. So I'm just going to have, I'll just use the resistor symbol here. And that's going to be in series with the battery. So again, we're using the simplification technique here. This still being R, and this one being R divided by 2. Okay, so then your resistance total now. Okay, so I've got this one here you can think of as being 2 over 2R, right? So that's now going to become 3/2 R. So you can see that the resistance has gone down now. Okay, so it's not as much. Okay, so then I'm now going to have E equals I times 3/2 R. Okay, and then when I solve for E, I guess I'll write it right here, E divided by 3/2 R is equal to my current. And 3/2 R is smaller than 2R, so you know that the current's going to go up. Okay, so that's how you handle that circuit, and you hopefully will be able to answer all the rest of the questions from there, you know, looking at power and things like that. Okay. We had another question with a more complicated circuit like this. You know, we've kind of done this already. This is a little bit simpler than the one that we've done. But you'll have to simplify this and work your way towards the 12-volt battery. You can start out by recognizing that this part's a series, and that's a parallel, and that's series. So we trace electricity out. It goes this way. Must go through this resistor. And now has this branch to go through, and then this branch to go through. But go ahead and simplify it. So here's our battery, like this. We have to go through the 7.5 ohm resistor, and then go down this branch here. and around. We can add these two together as series. That would be 14.7. So I've got a 7.5 ohm resistor here, a 5.6 ohm resistor here, and a 14.7 ohm resistor here. Now this circuit looks just like the last circuit. Now we have a one series resistor here and a parallel. So add these two in parallel and you'll end up with a circuit. And I guess we can put our 12 volts here. We'll end up with a circuit that looks like this. Two resistors in series. So we have 12 volts here. You'll have a 7.5 here. And I'll just call this a resistance parallel here. Okay, then you can get the total current by adding these two together as a series. And then what you can do is get the volts on this using V equals IR. And get the volts on this using V equals IR. In this case, we'll call it R parallel. Okay, and then you'll have the volts on this, and whatever volts you get here will be the volts on this one and this one. So therefore, you can get the current going through this branch using V equals IR. And then this will be V equals IR. And then unravel one more time to get this. You'll have the current through both of these being whatever you found here. And then use V equals IR to get the volts on this one. And V equals IR on this. The I here is whatever current you found here. And then you'll have volts on this and current, volts and current on this, and likewise. And then you use P equals IV to get the power on each of those resistors. And that's how you do it. And if you have any other questions, come see me in class.